All right. Well, welcome everybody to the 80th annual scientific meeting of CPDD here in sunny San Diego. I haven't looked outside, but it looks like the sun is already out. From what I've learned now, until about 9 o'clock it'll be foggy, and 10 o'clock the sun will come out. It'll stay out until 9 o'clock, and that'll happen today, tomorrow, the next day, and the next day. So that's great. Well, welcome everybody. We have people here from everywhere, all over the country, all over the world. That's what CPDD is all about. Before I move forward, you'll see the insignia up here. We've got hashtag CPDD 2018. I just want to let you know we're trying to move into the 21st century, and we've got a new social media committee, and we're trying to increase use of things like Twitter to get publicity out, to increase communication amongst young and old people. And for those of you young or old that don't know much about it, we've set up a booth to train you on how to use some types of social media, including Twitter. I can use that, even though I'm part of a Center for Technology and Behavioral Health. We can all use some help. Anyway, we've got, as usual, a great science program for you. We've got multiple symposia and workshops and forums and poster sessions. And to me, the poster sessions I like the most. I think CPDD has the best poster sessions of any conference I go to in terms of attendance and chances to talk to your colleagues, et cetera. And regarding the science program, I wanted to start with lots of thanks. We got a lot of people involved in CPDD that make this happen, and it is not easy. It is a lot of work. And first, it's the program committee. They do a ton of things prior to this conference in helping select and organize, and Bill Stoops has been chair of that for, I think, 2 years now. And I've listed his committee members up there, and I've also listed the executive office because they do a lot of work on the program as well. So if you get a chance and you see any of these folks, thank them for all their efforts, please. Oh, by the way, I forgot to introduce myself. I'm Alan Budney, and I'm the current president of CPDD. I know a lot of you, but I do not know all of you. And anyway, other people to thank. CPDD has many, many committees, working committees that do all kinds of things, not just to make this conference happen, but to help promote addiction research and help facilitate addiction research, help to publicize addiction research, et cetera, et cetera. And there's 18 different committees. That might not be exact because we keep adding some and taking some away. But there's all kinds of opportunities for people to get involved and to make things happen in the addiction world that can be helpful to not only CPDD, but the rest of the folks that are suffering from addictions, people interested in doing research or getting training, et cetera. So if you're on those committees, thank you very much for your time and effort. And if you're not and would like to be, just send us a note and we will find something for you to do. We have an executive committee, for those that you don't know how we operate. And the executive committee, I'm on that obviously, but Loretta Finnegan, who's up here, is our executive officer. Ellen Geller is our director of the executive office. Meg Haney is our president-elect. She takes over for me in, I think, about 58 hours, something along those lines. She can't wait. And Leonard Howe is our past president. Leonard has, devoted a lot of his life, the last 3 years, being president-elect president. So a lot of thanks and appreciation to Len for all his work. Jack Bergman is our current treasurer. The treasurer, as you can imagine, the financial operation to keep this thing going and keeping it all organized is a ton of work. And the treasurer is not a paid position, so Jack devotes a lot of his time and effort, and again, appreciation there. Last, I list Sandy Comer, and Sandy is our public policy officer. And I want to take a moment just to emphasize, if you don't know about CPD's mission in the public policy area, it's a big part of what we do, and a lot of our time and effort is devoted to public policy. And our current leader is Sandy Comer. She took over for Bill Dewey, who had been doing that for the college for many, many years. He's not here this year, unfortunately, but Bill trained Sandy well, and she's off and running, and we've got all kinds of things going. We work closely with a group, Van Scoyoc and Associates, run by Ed Long and Katie Van Landingham, and we work with them to advocate and educate. And who do we advocate and educate? Well, hopefully people across the country, but we focus a lot on the Congress folks, both local and national. And we're trying to impact policy. And it's very important because we're trying to figure out how to influence funding streams, how to shape bills and legislation, how to reduce the burden that it takes to do our research, all the kind of things that we struggle with in our academic lives and that people struggle with in their personal lives with addiction. We're trying to get the world to know more about. So a lot of effort goes in that direction. One effort in particular that Sandy started 2 years ago was a Advocacy Day on the Hill being in Congress in Washington. Here we try to get as many CPDD folks as possible to go to Congress and talk to the congresspersons and their staffers and advocate and educate about what CPDD does and what our issues are and what we think they might pay attention to that they could influence that would, again, help the public health in multiple types of ways. If you've never done this, it sounds a little scary, but it's a blast. You learn a lot. Everybody's very nice on the Hill. They're interested in what we have to say, and it actually can make a difference. I think NIDA and NIH are going to be doing very well the next couple years, and I'm hoping we can take a little bit of credit for the work we do in that to help influence funding going in that direction. The other thing I wanted to mention about CPDD is we take a lot of pride in travel awards, trying to support our folks in finding a way to get to the meeting to reduce costs. It's very, very costly to travel anywhere and to attend a meeting. Our meeting's relatively long, 5 days, 6 days, so it can cost quite a bit. But we have over 80 travel awards, or awards that provide travel, and another 60 or more where we offer reduced registration in different ways. So you should know about these and take advantage of them. If you really are in need of travel funds, there's lots of possibilities. Just contact us and we can tell you about the various ways you can perhaps earn some travel funds. Another thing that's kind of bugged me for a long time, I've been involved at this level kind of thing for a while, the business meeting. We have a business meeting on Wednesday, this Wednesday, 5 to 6, and we have it every year, and it's usually not that well attended, and I'm always wondering why. Well, there's no science, there's nothing exciting going on at the business meetings, but it is a chance to learn about the organization and how it operates, and be part of it, and maybe think about how you might contribute and give us some feedback. So I just want to put a pitch out for maybe, if you have some time, show up at the business meeting and give us your input and perhaps get more involved. So that said, I wanted to take a few minutes to focus on one idea, one part of CPDD, I think that the biggest strength of CPDD that I think deserves some emphasis, and that's that CPD is a very diverse group of scientists, and we do a lot of different types of science, and that's kind of what defines CPDD. Our program, if you look at our program, we touch on multiple areas. I've listed, behavior pharmacology, neuroscience, clinical trials, et cetera. I'm sure I missed some and mischaracterized some, but we do just about anything and everything you can think of related to addiction at CPDD. And that's relatively unique. That's kind of what defines this organization. And I think it's very important to recognize that. We even touch on just about all drugs. We've got the focus this year. This is the number of abstracts that came in for different drug categories. Of course, what's going on in the world now, opioids is the number one number of abstracts, and then you go to things like cannabinoids and cannabis and nicotine, et cetera. But we touch on everything. You can bring any type of research to this organization, and we're interested in it, and we think it's important. If you look at our awardees and plenary lectures, it reflects the diversity. This year, the President's Lecture is going to be given by a couple folks that work in the population health, epidemiology, health services area. I'm not sure how they define it, but that's how I see it. Our Eddie Award Lecture, that's our biggest award winner each year, is going to be given by a fellow that works in medicinal chemistry. And is going to talk on cannabinoid receptors. Our Fishman Award winner works in the area of human behavior pharmacology, treatment research. She does psychopharmacology. Our newest award, an Innovator Award that I'll tell you about in a little while, another medicinal chemist is going to be talking on this award, and this award involves a symposium, and there'll be a whole symposium on chemical approaches to development of drug abuse therapies. The Mentoring Award, our past president is going to receive that. He does work in behavioral neuropharmacology with non-human primates. And our youngest science award winner, for the Cochin Award, Kelly Dunn, she does work in the treatment area, health services, behavioral pharmacology. So you get the idea. We're a diverse group. And then we have these forums on media, policy, animal research, human research, government and academic and industry relationships. CPDD is truly a multidisciplinary organization, and we think that is our strength. And why are we multidisciplinary? Because addiction, drug dependence, whatever you'd like to call it, is a multifaceted, multi-determined problem that requires knowledge and science from all angles. And so we need to be working in all these areas and try to understand the data that come in from these areas if we're ever going to make great progress in the science and the efforts to combat addiction. So I just want to make a pitch. We can all benefit, obviously, from understanding each other's research and each other's science. And CPDD is a meeting which works to bring these scientists together. So they're all here. And I encourage you, if you can, to take advantage of this. Go to some talks or posters in areas that are different than your own. And if you don't understand it, ask them to explain it. How is this relevant? I mean, go to something that you have no idea and say, here's what I do, and see if they can tell you what it's about. It's kind of fun. It's a little intimidating, but give it a shot if you don't mind. So that said, on a little bit more somber note, you probably all noticed this year that we sent out a proactive message to increase awareness and provide support in the area of misbehavior, harassment, whatever you want to call it. You know, we're all aware that in our society there's a movement to be more aware and be more supportive of the type of things that are going on. And so we put this out after seeing that other scientific organizations are doing this. It wasn't in reaction to any specific thing that happened at CPDD, but I'm sure things have happened in the past. But pretty much it's just a message to respect your colleagues. Respect their science, respect their politics, respect their sexuality. And of course, harassment of any kind is unacceptable. But if you have concerns or if anything happens, just know we're here as well to help support you and figure out what to do about it. That said, welcome again to the 80th Annual Scientific Meeting. I'd like to turn it over to our Executive Officer, Loretta Finnegan. She is going to talk about the history of CPDD and tell us what we've been doing for 80 years and who's been involved, and I look forward to it. Loretta, it's yours. This is just, I don't have it. Oh, you know, slides. Oh, okay.
Good morning. Whoops. Happy birthday, CPDD. And that's to all of us, because we are CPDD. Born in 1929, the College on Problems of Drug Dependence, formerly the Committee on Problems of Drug Dependence, has been in existence and is the longest-standing group in the United States addressing problems of drug dependence and abuse. From 1929 until 1976, the CPDD was associated with the National Academy of Sciences, National Research Council. Since 1976, the organization has functioned as an independent body affiliated with other scientific and professional societies representing various disciplines concerned with problems of drug dependence and abuse. This birthday, however, is not from its origin in 1929, but the birthday of when CPDD began to sponsor scientific conferences, which was in 1938. Post-National Research Council, CPDD became an independent, incorporated committee. The members of the Executive Committee and the Board of Directors are mentioned in the historical article on our website. The two extraordinary events, which occurred late in 1976, deeply affected the future course of the CPDD. The traumatic, looking for some water. Sorry. The traumatic effects of the loss of the human testing facilities at the Addiction Research Center in Lexington, Kentucky, due to a moratorium on prisoner research declared by the Federal Bureau of Prisons and the loss of the National Academy of Sciences National Research Council sponsorship colored the events of the following several years, as well as contemporary activities of the CPDD. These incidents heralded the beginning of a tumultuous decade in the life of the committee. Upon retrospective evaluation, it was realized that the impact of the CPDD on the human testing facilities at Lexington had appreciably lessened during the past several years, coincident with the ARC status as the intramural research arm of NIDA. NIDA had been mandated to test only those compounds which were of interest to the U.S. government, not necessarily compounds which might be marketed by the pharmaceutical industry and for which the CPDD perceived a need to determine abuse liability in human subjects, with the thought that these new opioids might pose a public health problem. Furthermore, the ability of the CPDD to influence or even suggest which compounds might be evaluated at the Lexington facility had lessened considerably since Dr. Nathan Eddy's death in 1973. Thus, the CPD, coincident with its 1977 incorporation as a separate entity, began a search for an alternative to the Lexington facilities. The activities of the committee following incorporation were complex and extensive. These activities included 1, incorporation and reorganization, 2, purposes and goals, 3, animal testing, 4, human testing, 5, relationships with U.S. government and international organizations, and 6, funds and awards, and 7, conversion to a membership organization. The first meeting of the wholly independent Committee on Problems of Drug Dependence Incorporated was held at the International Inn in Washington, D.C. in February 1977. The primary objective was to organize the CPDD and to elect officers for the new corporation to meet the legal requirements for the committee to act as an independent entity under a consortium of professional societies. It may seem complex because since incorporation in 1977, the CPDD had to modify its bylaws many times to enable the organizational structure to best fit its needs. The apparent complexity was confounded by 2 facts. 1, the retention of the word committee in its name. After incorporation, the committee became, in fact, a corporation, but the old word was retained. Thus, an executive committee, various standing and ad hoc committees, and subcommittees of the committee were eventually formed. There was rapid evolution of the CPDD in its attempt to increase the depth and the breadth of its views far beyond those encompassed by the original CPDD before incorporation. In 1991, the CPDD evolved into a membership organization with a new name of the College on Problems of Drug Dependence Incorporated. For detailed information on our early history, please look at our historical link on our website, where you will find the definitive paper, The Committee on Problems of Drug Dependence, A Legacy of the National Academy of Sciences, a historical account, written by Dr. Everett May and Arthur Jacobson. This historical account is extremely detailed. Many names of people that you may have known, know now, or never known. But these names are the foundation of this organization. I believe that as members of the CPDD, we all should read this and pay respect to those wonderful men and women who really began this organization. Those early members of CPDD formed the foundation upon which scientists base many of their research studies today. Although the funding of drug abuse research has increased substantially since the 1960s, largely due to grants by the National Institute on Drug Abuse and the National Institute of Mental Health, significant research began much earlier. The research illustrates changing popular and professional attitudes toward illicit drugs and drug users and provides insight into the relationship between scientific findings and drug policy. Around the time of World War I, extensive drug use in the United States, a combination of morphine, heroin, opium, and cocaine, created a growing fear of drug abuse. A 6-year federal effort to control the distribution of opiates and cocaine led to the Harrison Anti-Narcotics Act of 1914. Regulations associated with the Harrison Act and promulgated by U.S. Treasury Department in 1915 indicated that the maintenance of non-medical addicts on narcotics to avoid withdrawal would not be considered legitimate medical practice. The federal government then began to use the act to prosecute doctors who issued prescriptions for that purpose. Drug abuse research in the 1920s seems to have been at a relatively low level of activity. The Public Health Service produced some estimates of the number of addicts and general statements on the nature and treatment of drug users. By the close of the 1920s, the Bureau of Social Hygiene decided to transfer its support of research to the National Research Council, where it was hoped greater central direction would be achieved. In 1929, the Committee on Drug Addiction, established by the National Research Council's Chair of Medical Sciences Division, existed. Its members included medical school researchers and key government scientists and administrators, including the head of the Federal Bureau of Narcotics, H.J. Anslinger. Their first task was to decide the direction of research, and their reasoning is quite instructive as to the state of research around 1930. The committee considered that further sociological studies were unlikely to help the drug situation. Given its resources, the committee felt that one drug should be targeted. Cocaine was considered, but dropped because it was no longer much of an abuse problem. Codeine appeared to be less addictive, thus posing less danger. So morphine was chosen as the target of this new research effort. The goal of studying morphine was to find substitutes that were not habit-forming. Scientists were well aware that they worked in a framework of law and policy that precluded maintenance and in an atmosphere of extreme antagonism to narcotic drugs. In addition to seeking safe substitutes, the National Research Council Committee approved 3 more tasks. 1, synopses of the literature on morphine and other addictive drugs were to be prepared. 2, based on the literature search, rules and regulations governing the legitimate use of morphine and other habit-forming drugs were to be established. And 3, a determination of where gaps existed in biological knowledge was to be made. The committee proceeded to attack the problem by working in 3 settings: chemical laboratories that would create possible substitutes, a pharmacology lab where these would be tested, and a clinical setting in which human subjects would be studied. New substances for trial were created first at Yale and then at Dr. L.F. Small's laboratory at the University of Virginia. The substances were then sent to a new pharmacology unit at the University of Michigan, headed by Dr. Nathan Brown Eddy, where they were tested on laboratory animals. Clinical facilities were meager until the narcotic farms opened in Lexington, Kentucky in 1935 and Fort Worth, Texas in 1938. These institutions, dubbed farms by the sponsor of the legislation and established them, who was Representative Stephen G. Porter of Pennsylvania, were in fact special prisons for drug addicts, complete with cells and bars. They were officially under the control of the Treasury Department, which was charged with enforcement of narcotic laws, but were staffed by public health service officers. It was not until the late 1960s that the facility at Lexington became a true public health service hospital. Eventually, the Addiction Research Center, under the leadership of Dr. C.K. Himmelsbach, was established at Lexington to determine the addictive liability of various compounds. Pharmacological research at the Lexington facility provided major contributions to the understanding of opiate and alcohol dependence and withdrawal, and included research on the quantification of opiate dependence as a physical or physiological phenomenon, and on the effect of methadone on opiate withdrawal. When it became apparent that Rockefeller funding would not be continued, the chemical and pharmacological work was transferred to the Public Health Service. At that time, in 1941, a non-habit-forming analgesic to replace morphine had not been found. However, many drugs had been tested, and experts were hopeful that compounds with a more salutary balance of effects, although still habit-forming, might be developed. Certainly, many of the pitfalls of drug testing had been recognized. Judged by today's sophisticated research, the methods were simple. Addiction liability was typically tested by substituting the test drug for a regular dose of morphine in a morphine-dependent person and observing the results. The relation of molecular composition to effect was considered, but at a level that could not take into account the actual shape of the molecule or the site on which it acted. These early studies illustrate the limitations of knowledge at the molecular level where pain relief and dependence occurs. In 1947, the National Research Council established a successor body, the Committee on Drug Addiction and Narcotics, which has been mentioned. Prominent among the reasons for this renewed activity was the appearance of methadone from German laboratories. Methadone had been substituted for morphine to meet German needs during World War II. Researchers' considerable interest in methadone's possibilities, together with other unfunded ideas for scientific studies in the field, prompted the group to consider asking pharmaceutical manufacturers for contributions to a research fund that the committee would administer. The National Research Council approved, and by the end of 1949, 8 firms had contributed a total of $18,500. This episode reveals the paucity of funding sources and the extremely modest amounts with which basic and practical research on pain relief was conducted immediately after World War II. There were other supports for research in this area. University science departments contribute some of their own funds to these studies. Furthermore, pharmaceutical companies themselves conducted research on analgesics, although their practice of sending new drugs for testing under the committee's auspices suggests that their programs in this area were not comprehensive. In addition to its funding from pharmaceutical companies, National Research Council Committee on Drug Addiction and Narcotics began to receive small annual amounts from the Veterans Administration and the World Health Organization. Research sponsored by the committee was varied and included studies of methadone as well as opiate antagonists such as nalorphine, naloxone, and naltrexone. Additionally, the committee advised the Federal Bureau of Narcotics and the Food and Drug Administration on the potential abuse liability of marketable drugs. The committee changed its name to the Committee on Problems of Drug Dependence in 1965 to meet the new definition of addiction, which was promulgated by World Health Organization. By 1977, CPDD had incorporated as an independent organization. It continued to grow as a locus of scientific interchange, later changing its name to the College on Problems of Drug Dependence. Drug abuse can be viewed from many perspectives. At different times and different contexts, each of us uses multiple vocabularies to describe and discuss drug abuse. Sometimes we use the vocabulary of choice and responsibility. Sometimes we use the vocabulary of health and disease. Sometimes we use the marketplace vocabulary, supply and demand. Sometimes we use the vocabulary of crime and punishment, and the list goes on. Scientific study cannot be expected to erase or reconcile fully our multiple understandings and interpretations of drug abuse. Were it not for scientific research, however, we would be unable to understand drug abuse from any of those perspectives. Were it not for scientific research, we would be unable to harness the social and political energy needed to respond to drug abuse in a rational manner. The majority of scientific knowledge about the drugs of abuse and their dependence properties comes from the early days of research accomplished by those associated with the Committee on Drug Addiction and Narcotics and its evolution to the Committee on Problems of Drug Dependence, and then on to the College on Problems of Drug Dependence of today. We should be so proud of our legacy and praise those brilliant men and women who led us through these years, many of whom still do. So I say happy birthday, CPDD, but mostly I say thank you for bringing us up to this point of drug dependence research. Finally, I had asked some of the members to see if they could send me some things that made them remember certain meetings that they attended, because some of you may be here at your first meeting and others may be here at your 40th. The board has a number of little stories that come forth, and Dasis Ficus sent this to me, which includes a very favorite person of mine, and I'm sure many of yours. Conversation overheard between Roy Pickens, newly elected member of CPDD Board of Directors, and Joe Brady, longstanding member, at the end of a very long day one meeting of the Board of Directors. Their discussion focused on the agenda planned for day two, beginning with continued discussion of the topic that they had already spent several hours discussing on day one. Roy, as a newcomer to the board, told Joe he was perplexed by the need for further discussion of the topic, ending with the question, what else could possibly need to be said about it? Joe Brady responded, Roy, you're right. Everything that needed to be said on that topic has already been said, but not everyone on the board has said it yet. And finally, I just wanted to end with one sent from Chuck Gorodetsky. I don't think there are many here who remember the annual CPD meeting in February 1965 at Baylor University in Houston, Texas, but I do. It was my first CPDD meeting. I roomed with Bill Martin. Government per diem was pretty low in those days. There were only a few hundred people who attended then, so you essentially got to meet everyone. I presented my first scientific paper there. It was a wonderful meeting experience for the beginnings of a lifelong career commitment, and I haven't missed a CPDD meeting yet. So congratulations to CPDD and to people like Chuck Gorodetsky, who faithfully attend our meeting every year. And I hope that those of you who are here today, whether it's the first time or the 20th time, that you too will realize the significance of this organization and what it has done for the science of drug dependence, and continue to work in this field and bring forth more and more discoveries as has been done in the past. Thank you.
Thank you, Loretta. All right, so we're going to move on to the award presentations. And first, I would like to invite to the stage Dr. James Rowlett to present the Stephen B. Holtzman Travel Award for Preclinical Investigators.
The Stephen G. Holtzman Travel Award was developed by a family and friends of Dr. Holtzman and is given annually or biannually to a predoctoral or postdoctoral trainee involved in preclinical research. This is this is a relatively new award, and really just to hit the highlights, this is for excellence in research. The awardee cannot have had any NIH support previously, and they receive free registration and some travel money. This award this year, I'm very pleased to announce, goes to Dr. Lais Berho of the University of Mississippi Medical Center. Lais is a native of Brazil, and she did her training at the Federal University of Sao Paulo in the state of Sao Paulo, where she received her Bachelor of Science, Master of Science, and PhD. Her PhD thesis was unique in that she actually did this at Emory University at the Yerkes National Primate Research Center with a collaboration between Dr. Leonard Howe, our mentor awardee today, and who is, of course, an expert in drug abuse, and Monica Anderson, who is a well-known researcher in the area of sleep. Upon graduation, she joined our group at the University of Mississippi Medical Center in the Department of Psychiatry and Human Behavior, and we're very pleased about this. And what I'd like to do, I could spend all day talking about her accomplishments, but I just want to highlight a few. Lais has received numerous scholarships and in particular a PhD fellowship from the Sao Paulo Research Foundation. These are extremely competitive. And she received one of these for her studies at Yerkes. If you type her name into PubMed, you'll get 35 hits. 34 of those are hers, published articles, and I counted approximately 21 peer-reviewed original papers, which I don't think I need to tell anyone, but I will anyway. That is an outstanding accomplishment for somebody at this point in her career as a second-year postdoc. The future is bright. She also has parlayed this productivity into a faculty position at University of Santa Cruz in Brazil, and is at UMMC independently establishing a sleep laboratory using sleep electrophysiology in non-human primates. Lais is interested in the intersection of sleep and drug abuse, and we are very excited to see what the future holds for her. And I think on that note, I'll invite Lais up to the stage to accept the award.
Thank you so much, James, for the lovely introduction. I am a strong believer that much more than hard work, the environment in which you grow up and develop and the opportunities that are given to you allow you to achieve great things. So from the wonderful family in which I was born, to the family I recently started with my husband, to the many doors that my scientific mentors and collaborators have opened to me, those are the real reasons why I'm here today. In particular, I would like to thank my undergraduate mentor, Dr. Roberto Frussa Filho, who introduced me to science, and to my master's and PhD mentor, Monica Anderson. Monica gave me the opportunity to come to the US and work with Dr. Leonard Howe, which was a very pleasant opportunity for me. And then Leonard one day came to me and told me that he had a postdoc opportunity for me with James Rowlett. So, of course, I just had to be fearless enough to say yes to literally all of those opportunities, but that was all. Like everything, the reason why I'm here today is actually because of this amazing team of people behind my scientific achievements. When I first got the notice of this award and I shared the news with Leonard and James, both of them went on to tell me how wonderful Dr. Steve Holtzman was, what a great mentor he had been to them, and how pleasant and knowledgeable he was. It is truly an honor to be given an award in his memory, and although I did not have the chance to meet him, I know that the impact of Dr. Steve Holtzman's actions is still alive as I see all of those qualities in you, my mentors. So thank you, my mentors, to all of the doors you opened me to, for trusting me and for giving me the opportunity to grow and learn from you every day. This award is really to your efforts and not mine. Thank you. Thanks. Thank you so much.
All right. Next, we have the Marty and Toby Adler Distinguished Service Award. No, I'm wrong. Sorry. We've got the Media Award. And if Meg Chisholm could come up, she's going to introduce our award winner.
Each year, the CPDD NIDA Media Award is given to an individual who has helped increase public awareness of substance use research and treatment. Nominations are solicited through members of the college, including its media committee. And I want to thank this year's committee members for their work in preparing and reviewing the numerous nomination packages. It's my privilege to present the 2018 CPDD NIDA Media Award to journalist Maya Solovitz in honor of her best-selling book, Unbroken Brain, A Revolutionary New Way of Understanding Addiction. Solovitz is one of the world's leading journalists on addiction. In addition to Unbroken Brain, she is the author of the book Help at Any Cost, as well as numerous reports on addiction in high-profile media outlets like National Public Radio, Vice, Scientific American, The Washington Post, and The New York Times. In her latest book, Solovitz combines her personal experience of overcoming heroin and cocaine addiction with a popular synthesis of the scientific literature in order to challenge both the idea of the broken brain and the addictive personality. From her lived experience as an IV drug user and her astute and accessible distillation of the science as a journalist, Solovitz argues that addiction is a learned behavior, a perspective familiar to us here at CPDD, for which she offers insights to the lay public around treatment, prevention, and overall drug policy. In recognition of her clear commitment to bringing this more nuanced understanding of the science of addiction to the public, please join me in recognizing Maya Solovitz as the recipient of the 2018 CPDD NIDA Media Award.
Well, I just want to say I'm truly honored and delighted and all of that good stuff. This really means an enormous amount to me. I've been writing about addiction and drugs for, God, like 30 years now. And for all of that time, I have relied on the work that you guys do, particularly NIDA. And I've been immersed in NIDA research data for decades at this point. And it's just great to be honored by some of the people who do that work and who oversee that work and make sure that that work happens. It's also really great to see that NIDA has always had a commitment to the science itself, regardless of whether it shows what the politicians want it to show or whether it shows exactly the opposite. And I feel like the science has shown us the way towards a better and more humane drug policy. In the late 80s, when I was addicted and when the war on drugs was at its ultimate height, there were lots of people who were just like, we should let IV drug users die of AIDS, and that this was a perfectly morally acceptable thing to do. We had to send the right message, and that was the most important thing we could do regarding drug use. Now, at that time, harm reduction, needle exchange, any of that stuff seemed completely radical, completely far out, completely insane. And yet research was funded on these originally underground activities. And it showed that far from being impossible to do and useless and wasteless and people are just going to go and kill themselves anyway, in fact, New York State now calls needle exchange the gold standard of HIV prevention, and it's actually easier to get people with addiction to use clean needles than it is to get men to use condoms. So the data there was overwhelming, and it has led to thousands of lives being saved. We now have similar work going on regarding the provision of naloxone for overdose reversal. Again, we're getting super good data from NIDA showing that, yes, people do want to save their lives, and people do want to save the lives of their friends and their families. So it's just like really been amazing to see these changes and to see people like me who have a past of addiction being treated more humanely, and to see people recognizing that stigmatizing people with addiction doesn't help us. The whole point of criminalizing a behavior is to stigmatize it. And we, I believe, are slowly beginning to recognize that that might not be such a good thing to do. I see one of my heroes here, Mary Jean Creek, who did a lot of the fundamental work on methadone, and it is really great to see the progress, which we are very, very slowly making with regard to medication treatment. And I say medication treatment, not medication-assisted treatment, since we have two medications that we know of, buprenorphine and methadone, that cut the death rate from this disorder by 50% or more. So it's not doing the assisting, it is the treatment. And while certainly people can benefit from counseling and all of these other services, we don't require people who have diabetes to get counseling before we give them insulin. We don't require them to have a perfect record of sticking to your diet and exercise routine before we help them. And we need to think more about that with addiction. It's been really great to see how the media has sort of slowly come along and gotten slightly better. We still see far too many cases of addicted babies, which is an impossible thing because addiction is compulsive use despite negative consequences, and dependence is simply needing a drug to function to avoid withdrawal. And we need to make that distinction these days also to protect people on maintenance who otherwise are seen as just substituting one addiction for another. No, they have moved from addiction to physical dependence, and the physical dependence isn't a problem if it's making their life better, which it usually is, especially since preserving life matters more than anything else. Anyway, again, this is such an honor. I'm so excited to get this award, and after years and years of working on this, it really, sometimes things seem to go backwards, sometimes things to go in horrible cycles, but I really do feel like we are gaining better understanding of addiction and therefore providing more compassion to those of us who have lived through it. So thank you.
Thank you, Maya. I strongly suggest if you haven't read her book, pick it up. I'm only about 60 pages in, and then these presidential duties took over. But you can see it's a wonderful perspective that almost all of us are going to agree with. It'll also stimulate some ideas, I think, for additional research areas for you. Next, now we do have the Marty and Toby Adler Distinguished Service Award, and Loretta Finnegan is going to introduce our winner.
The Honorable Professor Bertha Madras, PhD. For the past 32 years, Dr. Bertha Madras has been professor of psychobiology at Harvard Medical School and is located at McLean Hospital with a cross appointment at Massachusetts General Hospital. As a scientist, her traditional research laboratory discovered key targets of psychoactive drugs in primate brain, developed a novel class of imaging agents widely used in humans, and identified naturalistic genotype-phenotype primate models of human-based genetics. Her current research focuses on contrasting behavioral and molecular effects of THC and cannabidiol. As an inventor, she received 19 U.S. and 27 international patents with collaborators. As an educator, she has edited 3 books on addiction biology, developed the first elective addictions course for Harvard medical students, and created an ongoing cell biology of addictions course at Cold Spring Harbor Laboratory. In public education, with a team, she created a museum exhibit, a CD, and a play at the Boston Museum of Science entitled Changing Your Mind, Drugs in the Brain, which was on display for a decade and toured nationally. Dr. Madras served as Deputy Director for Demand Reduction in the White House Office of National Drug Control Policy, the Executive Office of the President, a presidential appointment confirmed by the U.S. Senate with unanimous consent. She catalyzed ESPRIT, screening, brief intervention, referral to treatment services on a national scale, screening for all drug use, including prescription opioids, fought for and obtained Medicare, Medicaid, and third-party billing codes to reimburse for these services, catalyzed adoption of ESPRIT in the Veterans Administration system and other federal healthcare systems, wrote the first published report of federal ESPRIT outcome data, and acquired United Nations endorsement for ESPRIT. The World Health Organization commissioned her to write an update of cannabis and its medical use. For the Vatican Pontifical Academy of Sciences, she served on a panel on narcotics problems and solutions of the global issue and edited the final summary. Dr. Madras served as one of 6 commissioners on President Trump's Commission on Combating Drug Addiction and the Opioid Crisis, along with Governors Baker, Christie, and Cooper, former Congressman Patrick Kennedy, and Florida Attorney General Pam Bondi, and was charged with the development of the final commission report. She has received many awards, one of which is the Fishman Award, which is a CPDD award. The Better World Report of 2006 cited her brain imaging invention as one of 25 technology transfer innovations, university to industry, that changed the world. On behalf of the College on Problems of Drug Dependence, I am pleased to present the Martin and Toby Adler Distinguished Service Award for outstanding contributions to research in opioid use disorders and to the field of drug abuse beyond scientific contributions. Dr. Madras. Thank you so much. There you go.
Thank you, my colleagues. I've been given 2 minutes to acknowledge this wonderful award. And as Ivy Carroll will remember, I have the dubious distinction of having presented 55 slides in 15 minutes at one of the CPD lectures. So I will try to adhere to this time frame. I thank CPDD. I thank all my excellent colleagues who are present here. I also acknowledge Mary Jean Creek and Marty Adler and so many familiar faces that I delight to meet every year. This is my 40th year of attending to this meeting. I especially would like to acknowledge the fact that so many of my colleagues have adapted over decades to the sinusoidal waves of substance use, of different types of drugs, as well as of different political and philosophical approaches to addressing them. Public service is unique. It is a unique type of endeavor which differs from scientific endeavor in a number of ways. As scientists, we have the luxury of caveats. We can balance our opinions. We can say on the one hand, on the other hand. We also always temper our conclusions, knowing that everything we contribute in discovery has yet another chapter, another way of looking at the data. In public policy, there are no privileges. We need to make decisions. We have to say quantal, yes or no, on policies. SBIRT at ONDCP and the World Health and all the others that Loretta mentioned, all of these required decision-making, and the caveats had to be essentially dampened in order to move forward. And we also have concerns that scientists may or may not have. Certainly they do have with clinical trials, but not with public policy in the same way. Because if our decisions lead to unintended consequences, we lament them. And we can also be the brunt of partisan and irrational media outlets. And I'll give you one quick example. On the Opioid Commission, we were all sworn in on June 16th, with the exception of Pam Bondi, because it required months of vetting by the FBI to ensure that we would all serve with honor and with ethics. And our deadline for the interim report was July 1st. We had 2 weeks to make that, and we knew we could not. There were over 10 media outlets that reported with breathtaking horror that we missed the 2-week deadline after our swearing in comparison with the fact that from 2010 onwards, death rates escalated, soared above any other numbers in our national history, and nobody really lamented those deaths. So I say to all of you, if you're interested in public policy, it is one of the most rewarding, one of the most treacherous, and one of the most worrisome forms of human activity, because we always worry of unintended consequences. But above all, I am, and I hope anyone here who's engaged in public policy is driven by only one principle, and one principle above all, and that is to make the world a better place than we found it, and to leave this world a better place than when we were born. Thank you.
Thank you, Bertha, for all the work you've been doing in that area. Fabulous stuff for many years. All right, next we have the J. Michael Morrison Award, and I ask Fran Levin to come up, present the award.
Hi, everybody. I'm delighted to be here today. The Morrison Award sets out to recognize outstanding scientific contribution and scientific administration related to drug abuse. Yvonne clearly is the embodiment of who should be honored by this award. This is going to be a little bit personal because I've known Yvonne for at least 27 or 28 years, and I first met Yvonne when we both worked at the Addiction Research Center, the intramural branch at NIDA. We were both fellows at the time, and we would often engage in discussions about what medications might work for cocaine use disorders. I guess 27 years later, this hasn't changed very much. But in any case, when I left Baltimore in '92, I've remained in contact with Yvonne over the years and have watched with admiration as his career has progressed. Most recently, Yvonne has served as the acting director of the Division of Therapeutics and Medical Consequences, where he was responsible for all aspects of operating the division, including scientific, administrative, and medical activities. He previously served as deputy director of the division for nearly 10 years, and within NIDA and NIH, Yvonne has been an outstanding citizen, contributing his time to numerous other activities, including serving on the NIH Clinical Trial Stewardship Reforms Committee, the medical officer for NIAAA, and chairing the IRBs for both NIDA and NIAAA. He understands how to liaison with universities, research institutions, and governmental agencies. In the past few years, I've watched Yvonne encourage pharmaceutical companies to jointly work with academics to test novel pharmacologic agents for cannabis and other substance use disorders. While I could spend at least an hour discussing all of Yvonne's administrative accomplishments, I'd like to get a little bit more personal. I have witnessed firsthand how much he's helped the junior faculty and fellows in my division. I have often suggested that they reach out to Yvonne for his sage advice when questions arose. Repeatedly, young investigators, and even senior ones, have found that the time spent talking with Yvonne to be extremely helpful. Often the questions have revolved around how to best proceed with proposals that go unscored, or maybe scored but unfunded. His pragmatism and insights have always been supremely helpful. But I need to emphasize that clearly Yvonne has not only been helpful to people at Columbia, my colleagues at other institutions have all repeatedly told me how supportive Yvonne has been to them over the years. He has a national reputation as someone who promotes the conduct of novel pharmacologic research and ensures that it's conducted in a safe manner. To quote my colleagues, Ryan Vandry states that I've interacted with Yvonne as he has worn many different hats, and my respect for him grows over each encounter. Yvonne provides valuable support to me when I had an R01 submission that was converted to a U1 mechanism. Yvonne provided great leadership and helped me navigate that process. Sharon Walsh noted, from the perspective of a NIDA grantee, I can reflect on my interactions with Yvonne and what sets him apart. Yvonne is kind and thoughtful. He is careful and deliberate in his choice of his words. He works hard to make things transparent, which is very helpful, particularly for less experienced investigators. Let me end by saying that Yvonne is an exceptional individual who has a strong commitment to excellence. Yvonne is experienced, effective, and an empathetic scientific administrator who also happens to be a superb clinical investigator. Perhaps most importantly, Yvonne is a man of integrity and showers people with his warmth, wit, and wisdom. For nearly 3 decades, Yvonne has been committed through his administrative capacities to develop humane and efficacious treatments for individuals who desperately need them. There is no one better that I can think of for this prestigious award, and I feel honored to include him both someone that I work as a colleague as well as a friend. Thank you, Yvonne.
Wow. Thank you so much, Francis. Thank you, Ryan and Vandry and Sharon Walsh for this nomination. I really, truly honored with this award. It's something that I couldn't even dream that I was going to be able to have this award in. So I want to say that I'm really honored with this award and honored that I'm receiving this award, that Michael Morrison Award for something from in memory of a person that has been such an outstanding health scientist administrator. I didn't know Michael, but I know from Dick Hawks that he was really a very human person, very good scientist, and that really his purpose was to advance the drug abuse science. So that's some of the things that I really want to be able to do have been able to do in my career. I came to NIDA in 1988, and as a Humphrey Fellow, I came with this fellowship, and I started to work with Bob Schuster, Ed Johnson, and Paul Fodella in the buprenorphine studies, which was an amazing experience. Then I worked with Francis Levin on the first double-blind placebo-controlled trial of carbamazepine for cocaine dependence. And as Francis said, we're still looking for a medication that can be approved by the FDA for the treatment of cocaine dependence. And we still are having the same discussions that we had 30 years ago about what is the best outcome measure, how we can really help people with the cocaine problem, and we haven't been able to fund it. But to find it, but I hope that I'll be able that we will, as a group, as a group of scientists, we will be able to find a cure for not only cocaine, but also other substance use disorders. I then left NIDA in 1995 and went back to my country, to Colombia, and came back to NIDA, to the extramural program. And I want to thank Frank Bocci, Alan Leshner, and Betty Tai for bringing me back to the extramural program. It has been an amazing experience to be a health scientist administrator. For junior investigators here, please consider a career in health, as a health scientist administrator. It's very rewarding. It's great to work with so many investigators that are so committed to doing good science. So I want to say that in this time, when I came back to NIDA, I came back as a medical officer, and I have been able to evolve and grow with the position, and it has been a wonderful experience to work at NIDA for the past 18 years. So I want to say also, I give a very, very special thanks to my wife, Martha, who's sitting here, and my daughter, Lina. We started attending, and I say we, because the three of us have been attending CPDD since 1992. And when Lina, our daughter, was 2 years old, and since then she has been attending, both of them have been attending CPDD, and we have made it a family event. So we come and we enjoy the company of everyone and the interaction with all the great scientists that are in this organization. So I want to end by thanking all of you, thank all the excellent scientists for your contributions to advance the science. That's what makes our career as a health scientist administrators very, very rewarding. When we see that your papers have been published in a good journal, that your medication is approved by the FDA, that you got an IND, that is very rewarding, and that's what makes my life so fulfilling in my position as a health scientist administrator. So thank you so much. Thank you for this award, and thank you for your friendship.
All right, now we've got the Joseph Cochin Young Investigator Award. Maxine Stitzer will introduce our awardee. Is there a YouTube or something that's coming up?
She has a video, is it going to be?
I think so, let me see.
I don't know, but that'll be for later. So the Joseph Cochin Award acknowledges and celebrates the accomplishments of a junior investigator who's been working in the field for 10 years or less. And when I learned that my colleague at Johns Hopkins, Kelly Dunn, was eligible and being nominated for this award, I was a little surprised because of all that she's accomplished. I thought, could it be in less than 10 years? But sure enough, Kelly got her PhD from the University of Vermont in 2009. Then she came to Hopkins, where she did a postdoc and joined the faculty. And by 2016, she was appointed to the academic rank of associate professor. Now, Kelly is one of those remarkable young people who've got great vision and great energy. Her research interests are primarily focused on the opioids, which is very strategic for this particular time. She has currently three R01s and an R34, and of course a whole gob of publications. Just to mention a couple of her main projects where she's made contributions, she's developed a web-based intervention, overdose prevention intervention for users, giving them some advice about how to prevent overdose, such as don't use when you're alone, have somebody with you. She's interested in opioid detox and looking at novel medications, including tramadol, that might be effectively used to improve outcomes for detox.
She's working with the opioid cannabinoid interaction in pain treatment, and she's got a very innovative project looking at genetic components of individual differences in response to opioid drugs. So she's very widely, broadly knowledgeable and active in the field of opioid research. I want to just mention, too, what a great communicator Kelly is. I've always been very impressed with her communication skills. When she came to Baltimore, she actively sought out teaching opportunities, which is not an ordinary thing. Most people just stay in the lab. She's, of course, asked to speak locally and nationally in academic settings. And she's very generous with her time to the media when they're wanting to cover issues related to the opioid crisis. So Kelly is a wonderfully accomplished young woman, and I wish that she was here today, but she's not. And why is she not here? Because she's any day about to deliver her first child. She decided this was the time to start a family, not knowing that she was going to get the Cochin Award, of course. So if we are lucky, she's going to say thank you to you through a video. And in any event, I hope that she'll be here next year to introduce her new addition to her family to you all. How do we get this video?
Hello, my name is Kelly Dunn.
Okay.
I regrettably cannot attend this year's meeting, but I wanted to thank the CPDD Awards Committee and CPDD for awarding me the Joseph Cochin Young Investigator
And there's the
Award.
plaque.
I'd like to also thank my nominators Maxine Stitzer, George Bigelow, Elise Wirtz, and my mentor Eric Strain, and to thank the numerous other colleagues with whom I've had the pleasure of working or training with over the past decade, and all the many friends I've made at CPDD. Thank you so much.
Well, I guess there's no picture.
That was good, though. Thanks, Max. All right. Thank you, Max. Congratulations to Kelly when you get back. Next, we have the presentation of the Mentorship Award. And Lais Barrow, can you come up?
So I have the honor and pleasure of introducing this year's CPDD Mentorship Awardee, Dr. Leonard Howe. This could very well be an award to his personal achievements. How do I skip this slide?
Oh, slide?
Sorry. There you go. Thank you. So this could very well be an award to his personal achievements, including having ran multiple marathons around the world, and recently, like really recently, 2 weeks ago, having finished a 530-mile pilgrimage through Spain, hiking an average of 16 miles per day for over 30 days. I'm pretty sure I haven't walked that much for my entire life. But no, this is not an award to Leonard's personal achievements. This could also very well be an award to his professional achievements, including having authored over 110 publications, 8 book chapters, and over 150 abstracts presented at scientific meetings, having been recognized for his contributions with an NIH Merit Award and a Senior Research Scientist and Mentorship Award from NIDA, or even having served on several CPDD committees, including being last year's CPDD president and currently being a member of the executive committee and board of directors of CPDD. But no, this is not an award to his professional achievements. For those who know Leonard, it's not surprising at all that this award is not about what Leonard has done for others, well, for himself, I'm sorry. This award is about what Leonard has done for others. It's about all the 12 postdocs, 15 graduate students, 70 undergraduate students, and 29 technicians that Leonard has directly mentored or trained over the years. It's also about the students he has indirectly mentored, such as the 21 doctoral students in whose thesis committee he was a member, and 20 doctoral students that he took into his lab during laboratory rotations. It's about the incredible impact that Leonard has had in our lives, both personally and professionally. Professionally speaking, that is very easy to measure based on how many of Leonard's mentees are now in important academic, leadership, and scientific positions, and I'm looking at some of them right here in front of me. And personally, I know I speak for all of Leonard's mentees when I say that Leonard has been and still are, as he would even reply to emails from the end of the world back in Europe, a wonderful, trusting, encouraging, and above all, selfless mentor. Mentoring is an extremely altruistic task, and Leonard has always done that with mastery and care to all of us. Leonard has always gone beyond to help his mentees achieve their goals. And Leonard, you know what I'm talking about. We will never forget everything you've done for us. Sorry. Thank you so much for giving us the best wings to fly and fly high, even though you knew that we would most likely end up flying away. Thank you for being there to support us along the way, especially should we ever fall during this path. And from driving that van full of students to Winston-Salem for lab exchange, stopping at Russell Stover, of course, and dining at Outback every single year, to providing guidance and advice on a daily basis, you have impacted our lives in the most positive way. This award is just one way to thank you and say how thankful we are to everything you've done for us. You get that plaque, but we are the actual winners for having had you as a mentor. So without further ado, it's my honor to introduce you this year awardee for this 2018 CPDD Mentorship Award, Dr. Leonard Howe.
Okay. So, Lace, thank you very much for that kind introduction and for initiating my nomination for this award. And congratulations to you for your Holtzman Award. It's very, very well deserved. Mike Nader and Paul Zodi, thank you for your letters of support. And I want to thank the awards committee for considering my nomination. It's very much appreciated. Mentorship is learned behavior, and I was fortunate to have 3 really outstanding mentors during my career. Larry Bird was my research advisor when I was in graduate school. He taught a naive student how to be a professional, and when I returned to Emory as faculty, he continued to nurture my development throughout until he retired. Steve Holtzman was never a formal advisor, but he took an interest in me as a graduate student, and he took me under his wing. And I learned about scientific and professional integrity from one of the best. And Steve continued to play a significant role as my mentor throughout his lifetime. I was only a postdoc with Bill Morse for 2 years, but those were the 2 most formative years of my life. And like Larry and Steve, Bill continued to stay engaged with me and to mentor me and shape my behavior for throughout my career. We also learn from our mentees. Mentorship is not one-directional. I want to thank my former graduate students and postdocs and junior faculty that I've mentored for the many life lessons that you all have taught me. I retired from academia at the end of last year, and I can say without question this is what I will miss most, the opportunity to interact with wonderful young scientists like these folks. Thank you very much.
Lace, you forgot one other mentee. I benefited from Leonard's mentoring as the president. Thank you, Leonard. Much appreciated. Okay, next we have the newest CPDD award, and this is the Innovator Award. And I think I've got a couple slides on this. I'm hoping. No, there's the ones I put up. Yeah, I think he has them. 1 second. Sorry. Anyway, the Innovator Award, I don't know if we have the slides or not. But anyway, the Innovator Award is a new one. It's supported by Indivior. Indivior was generous enough to provide CPD with a large donation, and in combination with the leadership, formulate this idea for an Innovator Award. The Innovator Award, as you can see now, recognizes individuals who have developed innovative approaches to basic science, clinical research, treatment and prevention science, any research area. So it's open to anybody in the organization that's come up with something innovative, and it reflects groundbreaking strides with potential for high impact. It's not a Lifetime Achievement Award. It can be won by a young person, an old person, a senior, a junior, et cetera. Anybody's open for it. If something innovative comes up, nominate your colleague for the Innovation Award. And what it supports is an award like any other. We actually have a statue which didn't show up, but we'll talk about that later. But and it also, what's interesting about the Innovator Awards, we decided to make it into allow the one person that wins the Innovator Award to develop a symposium. And so there's a symposium that will happen on Monday associated with the Innovator Award. So the winner gets to organize the symposium, and there's travel award funds for all his participants. Anyway, to introduce this year's winner, I'd like to introduce his mentee, I believe, and now colleague, Chris Cunningham. So Chris, if you could come up.
Thank you, Alan, for that introduction, and it's my pleasure to introduce a man who is he's a mentor, a colleague, and a friend, Dr. Tom Prizanzano, for this Innovator Award. I see an innovator as being one who sees a problem and then seeks out some sort of a new creative solution to it. And anyone who knows Tom personally and has been influenced by his work knows that this is absolutely something that drives him. One of the criteria for this award, as Alan said, was to recognize someone with a discovery that is bringing us closer to having great impact on substance abuse treatment. In 2007, so within the last decade, Tom developed a compound called hercanorin. Hercanorin at the time was the most potent non-nitrogenous mu-opioid receptor agonist. Not only that, it actually was found to be a biased agonist, which means this is a compound that only stimulates G proteins over beta-arrestins. And ultimately what this gives us is something that might have a safer therapeutic profile over compounds that currently existed. Now, this also brought in a brand new class of therapeutic and gives us something new that we can to research on. And ultimately, this paved the way for others to get into this space as well, such as Trevena Incorporated, whose lead compound, olaceridine, is currently in phase 3 clinical trials as a biased mu agonist that stimulates G proteins over beta-arrestins. Ultimately, this may lead into safer therapeutics that might have lessened potential for toxicities and overdose. Now, Tom has continued to pursue biased mu and kappa ligands, and this is certainly a hot and a developing area. And we'll hear a little bit more about that, I'm sure, at the Innovator Symposium on tomorrow that I will also be speaking at. Now, these developments are definitely, as the Innovator Award requires, bringing us closer to substance abuse treatments, not only in treating opioid abuse and dependence, but then potentially also other drugs of abuse, such as psychostimulants and cocaine. And that, I believe, makes him an excellent recipient for this award. Tom.
I don't really know what to say other than it's especially fitting to get an award like this, being nominated by one of your former mentees for this particular award, which I think is great. Obviously, I'm very honored and very humbled by this award. This is truly a wonderful organization and aimed at helping to address a major unmet medical need. I wouldn't be standing here without great training from former mentors. Dr. Kenna Rice and Dr. Richard Glenn at Virginia Commonwealth University, who both trained me how to be a scientist. But the real awardees are those who've actually worked in the lab, the talented group of postdocs and graduate students and technicians that I've worked with, as well as a great team of pharmacologists. As a medicinal chemist, I'm like to think that I'm pretty good at making molecules, but really where the magic happens is when you can give them to somebody else and they can show you what it does in an animal or it doesn't in a particular assay. And that synergistic relationship that exists between chemistry and pharmacology is one of the things that's really driven me as a scientist. Lastly, I'd like to thank my family, and particularly my wife, Deanna, who's not able to be here today because she's chasing my 3 children around at home. I thank you all very much for your kind attention, and I look forward to seeing you all at the Innovator Symposium tomorrow. Thank you.
So as I said, instead of a plaque, Loretta worked hard to find a little statue thing that's symbolic of innovation. I'm going to show Tom what it looks like because it's lost in a box on the way to San Diego. So this is what it looks like, Tom. It's actually pretty nice.
That's
I
fantastic.
Can't see that, guys? That's pretty nice. And what it says, it has an inscription. It's discoverer of hercanorin, the first non-nitrogenous G-protein biased mu-opioid receptor agonist. Congratulations.
Thank you.
Thanks. Now I'm going to keep Tom up here because our next award is the Nathan B. Eddy award, and Tom is the nominator and is going to introduce our award winner.
So it's really my great pleasure to introduce this year's Nathan B. Eddy Award winner, Professor Alex Macrianis of Northeastern University, where he is the George M. Beckwith Chair of Pharmaceutical Biotechnology. This is an especially proud moment for me as a faculty member at the University of Kansas, as Alex is a proud alumnus of our department, working under the late Professor Ed Smithman, who was a pioneer in the field of medicinal chemistry. So it's with great pride we have this case. And I know that Ed's shadow looms large over our department, and I can say without hesitation that I know that Ed would be very proud with this particular moment for you, Alex. Over the last 40 years, Alex has designed and synthesized many of the key biological probes used to characterize the pharmacology of cannabinoid receptors. First, initially thinking that cannabinoid receptors disrupted membranes, to more recently actually seeing that we actually have X-ray crystal structures of the cannabinoid receptor using one of Alex's ligands to help crystallize the receptor. He's made important contributions to the understanding of the molecular basis of cannabinoid activity by combining not only the fields of medicinal chemistry through structure-activity relationships, but biochemistry, molecular biology, and biophysics. And it's with great pride that I get to introduce who I think is one of the greats in the field of medicinal chemistry for this year's Nathan B. Eddy Award winner. So please join me in welcoming Professor Alex Macrianis.
Is there a... This here? Okay. Thank you, Tom, and congratulations for the well-deserved award. You always were a wonderful medicinal chemist. This is a great recognition of this. So, I have been involved in addiction research for a long time, and it has been a really rewarding experience to be working in this field. And I ended up putting a lot of effort in the field of cannabinoids. In fact, my career has been very closely intertwined with the field of cannabinoids. And together with other colleagues, many of them here, we have worked to see this field advance. And I thought I could present you a travelogue of what my experiences have been and how the field
has grown. So some of this may be technical, but consider it a travelogue with a lot of pictures, and I hope they won't bore you. So this is the female plant of cannabis. And by the way, the female is the much more important of the two genders in the cannabis field. And to start from the beginning, this was the main constituent of cannabis, which is delta-9 tetrahydrocannabinol. As you see, it's a terpene with a leaf, which is an important leaf, well recognized today. It received a lot of kudos. And the way this whole story started, which we could call the beginning of the latest cannabis development, was back in the mid-'80s when, with the help of NIDA, who had encouraged us to put together a program which would bring in people who were working in the cannabis field at the time. And this was a way of pushing the field forward, and it was a very timely one. As a result of this activity, we brought in a lot of people from industry, from other places. And 1 year following this event, this book was published, and at the same time, the cannabinoid receptor was discovered. So the first item in this was the identification of a test that indicated that this could be a G protein coupled receptor. This was done in the lab of Aline Howlett. And then this was followed by the synthesis of a good compound which could be radio-labeled, and this was carried out by a very distinguished speaker sitting in this room here, Dr. Kenner Rice. This was used by Mike Herkenham to show, in fact, that there are the locations of the receptor in the rat brain. And of course, at the same time, working in labs very adjacent to each other at the NIH, the clone of the receptor was discovered. And at our side, we had prepared these radioligands that bind covalently to the receptor, and this allowed us to show on a gel that in fact this receptor is a protein, and beyond that it gave us an inkling that there may be a second receptor there, which we call the CB2 receptor. The two receptors, there's classical G protein coupled receptors, 7 transmembrane helices. They look very much alike. CB2 is a little shorter. And they're present in different parts of the human body. And you see that the CB1 is very heavily populated in the human brain. In the animal brain, it's the most populated G protein coupled receptor. On the other hand, it's present in many other organs. The CB2 is mostly localized in cells that are related to the immune system. And the two big players in this field, you have anandamide and 2-arachidonyl-glycerol. They're two important players, not very potent molecules, and they form the endocannabinoid metabolome together with many other of these molecules. So we had to make a decision at the time to start developing the tools which would allow us to probe this very interesting new system, and also perhaps to open the door for developing medications that could be obtained by modulating the endocannabinoid system. So among the first ones was imaging the receptor in the brain. This was done using a SPECT method, And this is the imaging of the receptor in a rat brain with the compound AM281. And then that compound was used to imaging in vivo in baboon. This was done at Brookhaven Laboratory with a lot of distinguished scientists. And Dr. Volkov was a young scientist at the time, very supportive of this work. Among the other things we showed is making a compound that is stable. Problem with the endocannabinoids, they are unstable. So if they're unstable, you can't really study them. So this compound turned out to have a good traction. We call it AM356, known today as R-methanamide, a stable endocannabinoid. In other words, it doesn't get hydrolyzed by the deactivating enzymes. As a matter of fact, this compound, very recently, we managed to also make it stable for the cyclooxygenase 2 enzyme, and that will produce a new molecule. It should be coming out very soon in the literature. And also the antagonists. So the CB1 antagonist, the first CB1 antagonist was obtained by the company Sanofi, and our friend, we made a similar one. But we had also discovered an antagonist at the time, which worked pretty well in vivo, but we couldn't tell exactly what it was because it didn't bind to the cannabinoid receptor. It turned out we had discovered a CB2 antagonist before the receptor was discovered. So it was a very nice story here. Now, what's the biochemical system? Well, we have, as I said, two types of systems. We have the phytocannabinoids and we have the endocannabinoids. The phytocannabinoids, we know that the cannabis ingredients here, delta-9, THC, and some others. The endocannabinoids, we worked on these things to see exactly how they operate and how come such a dissimilar molecule could go in the same place, the same receptor. It turns out we could forward this, and we showed experimentally that this molecule occupies here helix 6, and this is the helix that modulates the system and produces the effects. Additionally, at the time, a curiosity was found in collaboration with Dr. Piomelli. We showed that there is a system in the cell which allows the molecules to be transported inside the cell. And by blocking this transporter, we were able then to increase the concentrations of these compounds, these endocannabinoids, and as a result, we could then activate the receptor indirectly. It was a very nice story. It took some time. We still don't have the full answer of this. I like to call it an endocannabinoid system. We also showed that these molecules, to reach their receptor, they have to travel. And the travel that happens is through a membrane. And it turns out that the molecule orients itself in a certain way, travels through the membrane. It doesn't come from outside. It comes through the membrane and then interacts with the cannabinoid receptor. It was an interesting concept which is very much adopted today for a lot of the receptors that are interact with lipophilic compounds. Now, what about the targets? Well, there are several targets here. There are the two receptors, but then, and as you see, these are presynaptic, and these receptors operate through the formation of ligands, which are the endocannabinoids, and the signal is given, to produce these ligands, and this signal happens to be many times calcium ion. So unlike the other hormones, where they are packed in a small vesicle, here these molecules are produced upon demand. And upon demand then, they involve a lot of enzymes which form these compounds, but also they deactivate the compounds. So as you see here, for a chemist, it was a very nice plethora of targets to make compounds for that can modulate the whole system. Here is a summary of these. You see, this is the anandamide here. It's hydrolyzed by a number of enzymes. It's a fatty acid amide hydrolase. There's an enzyme called N-acyl amidase. There is a second FA2 enzyme. On the other hand, the enzyme that hydrolyzes, get mixed up here with these, okay? The enzyme that hydrolyzes the 2-AG is a compound called monoacyl glycerol lipase. We also have the transporter. So we said, okay, let's work on these and let's make ligands for these so we can understand how these things control the endocannabinoid system. Basically, we want to enhance the levels of these endocannabinoids in the brain. So instead of activating the receptor directly on the receptor directly from the endogenous ligands, we do it indirectly by breaking down the enzymes that deactivate the endocannabinoids. So making inhibitors of these enzymes became an important task, and we decided to work on several of these. I marked them here, and they've been quite productive. Now, how do we approach this issue? Well, our goal there was to produce new ligands, new compounds. And we wanted to use our approach for making this a process which involves getting information on what type of compounds to make. So we decided to use methods which are generally accepted as target-based design. So to make a target-based design, you need to know something about the target. And that led us into a situation where we had to study these targets, whether it be enzymes or whether it be receptors. I'd like to show you some of the technologies we have used to study these targets. One thing we did early on is we made all of these molecules there because unlike the general perception that the CB1 and CB2 are activated by two ligands, they're actually activated by a number of ligands. They're all in the same family, but these are the most prominent. So we needed to have tools with which we can measure the levels of these ligands all around. So we went ahead and made all of these and deuterated them so we can get very accurate measurements of these molecules in any particular test system. We use them today as biomarkers. There are, for example, diseases that involve changes in the endocannabinoid system. We can have a drop of blood, measure the endocannabinoids, and see whether these affect the particular disease, and of course, give us then indications for developing biomarker tools. So, to give you a glimpse of what type of methodologies we have used, I'll show you some of the methodologies we've used, and I'll focus on this enzyme, which we like a lot. We've worked on the other ones too, but this we spent a little bit of time. And again, as I said, we wanted to get information on the structure of the function of the enzyme, because by having this information, we can design then molecules that are based on the target. That makes it a rational drug design approach. So here is monoacyl glycerol lipase, and it hydrolyzes the 2-AG analog here. This is the enzyme itself. And we have to purify it, isolate it, get numbers on it. And here we use mass spectrometry to identify the site into which the ligand goes in. And here we reconstructed the deactivation of this enzyme. And here we have a good inhibitor. And here is the... then we used a lot of nuclear magnetic resonance there to enlarge the specifics and get details about the individual amino acids, etc. And there's a fair amount of stuff you can get from this. You can see how these 4 peaks were very important because they can characterize all the modulations that this enzyme happens to it. And here we reproduce this, getting a 2-dimensional NMR spectrum of the enzyme itself. And then we have another place where they have other important peaks, and also magnifying these. And we showed that these particular tetrad here of peaks can guide us into identifying how the enzyme is being modulated. Do we want to make it long-acting or a short-acting? Do we want to eliminate it completely, or do we want to eliminate it partially? This is the type of information we have used. And this is 2AG reconstructed using combination of RMR, mass spec, and also the computational work. And you see here we have spent time identifying these 4 histidines. So now we can go ahead and plan to produce molecules that affect these 4 histidines and exactly where they are. You see this is the one, another one, second, third histidine, and identifying one at a time. So now we know exactly where these are, and we can tell where the molecule fits on the enzyme. So next to that, we found something interesting in this enzyme. For an enzyme to be deactivated, you go to the active site of the enzyme and try to inactivate that site, either by attaching an antagonist there, covalently or non-covalently. In this case, we found that we could inactivate this enzyme allosterically. In other words, we could go far away from the center of activity and inactivate that particular amino acid, which would allow us then to produce antagonists that are deactivating the enzyme allosterically. And that serves us as a possibility of developing new medications. Now keep in mind that all our efforts here with the biophysics and all of that is how to get information to develop new medications. So here we have how we have identified. So the way we found out about this, we've made a mutation, which was about 22 angstroms from this, which is quite a bit. And once we mutated this particular amino acid, then the enzyme was totally inactivated. So we followed this process because we're interested in how we can reconstruct this and produce molecules that could inactivate the enzyme long distance, which offers some advantages. And here, a little more on it here. You see here reconstructing the enzyme itself. Turns out the enzyme itself has a way which opens and closes. It's called a lid. We have reconstructed the lid here and produced the enzyme here. Actually, I don't have the slide that moves here, but you see that there is a slight movement within the enzyme, and that is what determines whether the enzyme is active or not. And we put it through some computational work here, dynamic simulations, etc. So another method, which is called HXMS, that method is interesting because you can look at a protein and you can identify where the particular piece of the protein is in the structure by looking at the exchange of these exchangeable protons using an interesting combination of this methodology, which helped us identify where the moving parts and where also the ligand goes in the enzyme. And here you can see how the ligand then, this is a very good enzyme inhibitor. And also we can show that the enzyme itself is not a membrane enzyme, but it's like to sit on the membrane and have its action here, but it's immobilized in the membrane itself. Now, shifting gears, a method we developed recently is a way where we can control how long the ligand can stay in the body? Can we make compounds with specific time with which they can operate, whether it's short or long? And the way we approached it is this method, which you could call the soft way. We put a little kink right here. It's an ester bond. And we put this compound in, produces its effect, and then the enzymes in the body hydrolyze it and gives you inactive compounds. So by playing around with the chemistry around this, we could do that also in a different part of the molecule. And you can see then we can produce molecules that have much shorter or longer time of action. And as a result then, we can produce medications now which can act in a specific time element. This way we can develop medications that show much reduced tolerance, and also medications that produce no products from the compound itself. And that's a very good compound. It's a compound I like a lot. Nabalone is, of course, one of the compounds, the only CB1 agonist synthetically made, still in activity, but you see nabalone produces its effect, which is acting for a long time here. But our compound, which is a modification of that, we can make it work on a shorter period of time. So if you want to make a compound that is a anti-pain compound, an analgesic compound, you don't have to have it for a long time. You can make it for a shorter time. And we tested this, and we show that this molecule has much less tolerance than other compounds. Produce called LAPS, which I'll go very quickly through. And what we do, again, our target here was how we can find out where the ligand is in the receptor. That was initially a tricky business because the receptors are very difficult to crystallize. So we developed this method, and basically what we do here is we put little groups here that can go and attach themselves to the receptor. Then we purify the receptor, get it out, and find out where they are attached. And these are two of our friends here, molecules, and they can attach themselves here or in two different places. And you purify this, and then our task is to find out where they are attached. We can do this either by making a lot of mutations, and you see how we made this is a very nice compound, 841. And we pre-treat the receptor. It doesn't have any sites anymore, showing that 841 is sitting at the active site. And then we could show now the ligands now don't bind. And we wanted to find out what is the place where the active molecule was. So we made molecules on the mutants. And the one that doesn't work is the one where the site is. And you see, you do also by mass spectrometry, and we show where the ligand sits. Now, 841 turned out to be a lucky molecule because it turned out paradoxically to be a very potent compound, so potent that we called it a mega agonist. You see here, if you look here, if you take the compound without that group on it and you compare it to the compound itself, it's about 50 times more potent. So we were very happy about this. We even got a patent on this. And you see how potent it is in vivo. You can create efficacy with 10 micrograms. 10 micrograms, that's right. And it shows it alleviates experimentally induced intestinal inflammation and so on. Also, we had been interested in looking at biased agonism, and we worked on that. And you see here, by using this LAPS method, we have shown that molecules can interact with the enzyme differently. with a receptor differently. In other words, you could make a ligand that produces certain types of effects, or you could make another ligand that produces a different types of effects because they signal differently. This was the object of this project. Now, more recently, working very closely with a group in California and a group in Shanghai, produced the first crystal structure of the CB1 receptor. It took a long time. This young lady here, very smart, from Shanghai, produces the first crystals. And this is our molecule here, which is a very nice molecule. Looks like it may become a drug sometime. And you see, we find that the enzyme sits right there. I'm sorry, the ligand sits right there. This is a CB1 antagonist. And then you can use this to model and see how all the other molecules interact. Now, the first molecule we used was an antagonist. We wanted to make also an agonist, which we did. And when we did the agonist, we got another crystal. In fact, we used two agonists here, and one of them was our friend AM841. And again, you see here that the agonist sits in the receptor. And now we're comparing where the agonist and where the antagonist sit. Very interesting. You see, this is the antagonist right here, almost a straight line, and this is where the agonist is. Meaning that you can produce molecules that can either activate the receptor or deactivate the receptor. It's a lot of power for designing molecules. And here it is. This is how the antagonist, how the agonist sits and how the antagonist sits there. Turns out, actually, when the compound goes into the antagonist mode, uses a much more expanded version of the protein. We had hypothesized that it happens through modulation of helix 6, which we had shown in the past how the structure is here, and a hypothesis about how the receptor is activated. And you see that helix 6 starts out by having a little kink. Oops, let me go back. By having a little kink here, straightens it out. By straightening out the kink, you break a salt bridge here, and the receptor is activated. Okay, now, so I'll spend the rest of the time talking to you because really I've been talking about ligands and molecules, etc. Can we do anything with drugs? So I'll show you some of the efforts we have here with the drugs here. And I'll talk about the antagonist, which initially started as a drug to reduce the appetite. We talk about neuropathic pain and also neuroprotection. So, with regard to obesity, the company Sanofi had made a major effort and discovered and developed a drug which was approved in Europe but not approved in the US. And the way they wanted to treat obesity is by reducing the appetite. And they said, well, if you smoke dope, you like to eat. If you do the opposite, you don't eat. So if I produce the opposite of dope, I can produce a molecule that helps you not to eat. That was the initial thought that Sanofi used. We had made a parallel thought at the time. If you smoke dope, you like to eat. If you do the opposite, you don't eat. If you produce dope, though, you get also happy. On the other hand, if you go do the opposite, you may get unhappy. You may get actually now have the opposite and have conditions we don't like. And that's what happened with the Sanofi drug. It produced depression and nausea. So can we produce a molecule that inhibits the CB1 receptor but does not produce nausea and depression? Just to refresh your memory here, and you see we have a partial agonist. Delta-9-THC is a partial agonist. Full agonist, CP55 or 4054. And you have here SR, which is an inverse agonist. And our compound, the first neutral CB1 antagonist, was AM4113. somewhere here at the 0 point. And again, here represented, we have the agonist is a GI, so it reduces the level of cyclic AMP. Partial agonist reduces the levels, but less so. The inverse agonist increases the levels of cyclic AMP, and we wanted to make a compound that produces no effect on the cyclic AMP. Binds to the receptor, prevents the endogenous ligands from producing their effect, but does not affect the level of cyclic AMP. And sure enough, this was our first effort, AM4113, a nice compound, still being pursued. And here we tested this compound because we had to show that this molecule has an effect without having the biological activity of the inverse agonist. So this was tested in hippocampal tissue. There, if you test, we use then the Sanofi compound, and you see that this reduces the level of cyclic AMP using a hippocampal tissue model. On the other hand, our compound does not. This was a proof or evidence that this molecule is pharmacologically distinct from the inverse agonist that Sanofi had produced, and not only Sanofi, but many of the drug companies had produced at the time. In fact, 5 or 6 drug companies, and they all withdrew them because of the side effects. And here we have our compound. This is the Sanofi compound, but it reduces the food intake, but produces effect here, nausea. And our compound reduces the effect but produces no nausea. And we tested it on nicotine self-administration, which was done in the labs of Dr. Goldberg. And you see that it does work for nicotine self-administration program. It also works for CB1 neutral for THC self-administration. So it's a good candidate for producing medications to combat self-administration either of nicotine or THC. And very recently, we have shown that it also affects heroin intake. So to summarize this, what we have, so this is the SR, this is our compound. This produces emesis in ferrets. This produces anhedonia, sucrose, immobility. So we use a swim test, and this was done by Dr. Jukiewicz. No effect here. And the analgesic effects, I'm sorry, the anxiogenic effects, they are not produced here. So it looks like, at least preclinically, we have now a way to go and produce compounds that work in addictive conditions. This is the latest of these, and this was done intracranial plane stimulation. And you see again that SR produces the negative effects based on which they had predicted that the Sanofi compound would be anxiogenic, and in this case, it does not. This shown again another way to show that the compound, this is SR, this is the swim test. Now, we showed that the 4113 can antagonize SR, which is a proof that they work on the same site. And from then on, then, can produce these. We have new compounds, etc. But it's a very positive place to look for developing medications against nicotine, against cannabis, and recently heroin, which we are pursuing now. This is a compound that was not only a neutral antagonist, but it was also not brain penetrant. And this is a very good compound to be used for fibrotic conditions like liver fibrosis, renal fibrosis, etc. And you see here, it does work, reduces hepatic injury of steatosis. Now, this is being pursued now for conditions, fibrotic conditions. And we hope to develop medications in two directions. One direction was to produce antagonists that are brain penetrant, but are neutral antagonists that would produce the same effects that the Sanofi compound produces in humans, because it had been tested, and in fact, it does reduce nicotine intake, and it does reduce and interact with cannabis. However, it does have the side effects. Our job was to show that it does the same thing, but it doesn't have the side effects, which we showed by producing these neutral antagonists. Another place we have tried to contribute is the CB2 receptor, and at the time we had the general understanding was the analgesia produced by cannabis was due to the CB1 receptor, and at the time we tested, we had made the first CB2 selective compound, and based on that, we're able to show that the CB2 compound can also produce analgesia, although an analgesia of a different kind. This is working with Dr. Homan, and we show that 1710 reverses paclitaxel-induced neuropathic pain. And here it is, you see concentration dependent. And here we've made a variety of those. They're wonderful CB2 selective antagonists, and they all work very well in neuropathic analgesia. Basically, the CB2 is best because there's been a lot of discussion on CB2, and one thought that it works in animals but doesn't work in humans. The other thought is that perhaps we don't have the right indication. And it seems that it works best for inflammatory conditions, conditions of inflammatory pain. And this is nicely represented, a slide from Dr. Homan's lab, showing you that CB1 produces all the side effects, but you can get the same effects with CB2 without producing the side effects in the brain. Finally, fatty acid-amide hydrolase for neuroprotection. We made some of the first Phi inhibitors, 374 and 404. So we have a model here where we show that we can produce a neurodegeneration, in other words, killing the neurons through a glutamatergic insult. So we inject in the hippocampus, we inject canic acid, and you see how it affects it. And this is a slice after we pre-treat it with this molecule, these two molecules here. This is a Phi inhibitor, and this is transport inhibitor. We worked more on this, and you see here another version of our molecule here, again 374, and we show that this molecule, when given, it increases the levels of AEA, meaning that we inactivate the enzyme that deactivates AEA, so we then get an increase of AEA in the brain, which is a CB1 agonist, and then that's how we protect, because one of the key roles of the cannabinoids is to neuroprotection. And there's a little more with these, and we've advanced it quite a bit. This is nice. We use a compound here which is more advanced, and you see here it can also work after 5 hours delay. In other words, you can produce the insult, and then after 5 hours, we give the compound, and the compound works. So that was a nice one, and we're working on these things. And you see here that it doesn't have the side effects which the CB1 agonists would have. Finally, and this is the seizure protection. Of course, it does work very well with seizure protection with our colleague, Dr. Ben Barr. This is a very nice compound, 6642. It's a non-covalent compound, non-covalent Phi inhibitor, and it's prime time for development. Now, the last two slides I want to show you is because that's something that came out from the work we had done on producing the crystal structures. And generally speaking, if you want to make a compound that sticks on the receptor, you either wait for a lucky break or you produce a covalent ligand. And we were under the impression that the only way to do it for sure is to do a covalent ligand, like 841. You do the covalent ligand, it goes in, sits on the receptor, doesn't get out, and then the receptor is inactivated. We found out that you can do it also by going in and making the compound stick without a covalent bond. So I give you two examples here of what can come by producing compounds like these, how they can be useful, not only in pharmacology, pharmacological testing, but also perhaps in making medications. So this work was done in collaboration with Michelle Glass, New Zealand, excellent person who worked very hard on the G proteins, and she had observed that if you activate the CB1 receptor, it's a GI-GO receptor, signaling receptor. However, there is also evidence that it produces under certain effects a GS. So the same receptor can either be GI-GO or GS, with, of course, pharmacology consequences. So by using our compound, she was able to eliminate the GI-GO component of the receptor and then provide evidence that this compound produces signaling through the GS mechanism. The second, so this is the molecule, and it's a nice molecule. It's actually a covalent binding molecule. And it's a way of really eliminating the CB1 mechanism. And actually, I like to call it a chemical knockout. So if you want to eliminate the CB1, instead of making the knockout, you could use this compound, because this thing can stay and last for a long time. And you see here, we use the other compound. This is the molecule we've used to crystallize the receptor. And you see this is done. This is in Dr. Parone's lab. And you see that this is given in monkey. And you see it can last up to about a week. So there's a molecule. You can give it in, and it can inactivate the receptor for a week. And it's not a covalent compound. So I think it may have some interesting possibilities, including the fact of making long-acting compounds for addiction. Well, it was a quick travelogue here of these, and I thank you for your patience going through all of this. These are my friends and colleagues. We get together once a year, and this is a little older than, but during that time, this particular day, we had done it near the ocean. And of course, very thankful to them. And of course, very thankful to NIDA, who has financed us all. And most thankful to the American taxpayer. Thank you.